Nowadays, I use the step up motors mostly in my projects, and I don't know the proper way to control them because it is not like a normal DC motor. Let's see what is the difference.
Ever wondered what makes a stepper motor different from a normal DC motor? Why do some machines hum and click while others just whir? Today we delve into the world of motors, specifically the intriguing stepper motor. First, it's essential to understand that a stepper motor is a type of DC motor, but not just any type. It's a motor that moves in discrete steps. It's like the sophisticated cousin of the regular DC motor. A normal DC motor spins freely when power is applied. It's that simple. The speed depends on the voltage applied, and the direction of rotation depends on the polarity of the power supply. Well, a stepper motor doesn't just spin freely. Instead, it has a series of electromagnetic coils arranged in a circle around a gear-shaped piece of iron. These coils are powered in a specific sequence, causing the gear to align with each one in turn, effectively stepping around the circle. Think of it as a dance. The coils lead and the gear follows, one step at a time. But this isn't just any dance, it's a dance where each step has a precise degree of rotation. This precision is what makes stepper motors so valuable. They can be controlled to rotate a specific number of degrees or steps. This makes them ideal for applications where precise control is necessary, such as in 3D printers, CNC machines, and even digital cameras. But there's a catch. Stepper motors need a special device called a driver to control the sequence of power to the coils. The driver functions as the choreographer, dictating the dance sequence for the coils and the gear. Without the driver, the stepper motor would be like a dancer without a choreographer, lost and confused. The driver ensures that the power is applied to the right coil at the right time, guiding the motor through its steps with precision and grace. In conclusion, stepper motors are a special type of DC motor. They move in precise steps, controlled by a sequence of power to a series of coils. They require a driver to manage this sequence, making them more complex, but also more precise than regular DC motors. Remember, it's the stepper motor's precision and control that make it a key component in many modern technologies. From the precise positioning of a 3D printer's nozzle to the intricate movements of a CNC machine, stepper motors are truly a marvel of modern engineering.
I ordered a driver and some kind of ribbon cables to make the connections with the Arduino and the driver and the stepper motor. Let's open it. Yes, I got the ribbon cables, a potentiometer to control the speed. Let's see each one of them. These are the ribbon cables. You can see male to female connections I have. And this is female to female. And next, these cables will definitely help me to for the good connections. And this is a potentiometer of 10K value, 10K ohms. This will be helping us to control the speed of the stepper motor. And basically this will have a threaded portion. You have a nut over that. While designing, you will see the details in detail. Let's see the 12 volt connector. This is how the 12 volt connector inside it will be looking like, the plus and minus polarity with two different terminals. And this is the receiving connector which will be assembled in our box. This is having two terminals inside. And then these are the cables, potentiometer again. Let's see how the connections. I have this whole enclosure for the Arduino, but that cannot be used for now because I need to include the driver and extension board inside the box. But this board is only made for Arduino. Let's take the DRV8825. Let's understand what it is used for. Let's take the data sheet and see what are the pin in and pin out. This is how it looks like. Number of connections are high, so I need to bring some module to assemble this DRV8825. So I purchased this from Amazon, which will give more number of connections in and out with the proper assembly. This board is having all the input and outputs combined together. Let's take the motor. This is stepper motor of NEMA 17 grade. NEMA 17, it means that it is a frame size of the motor. It has 4 terminals. You can see here the connector. You can see the bottom of the serial number. You can search for the data sheet. This data sheet says the phase current is 1.9. So it will be useful to measure the Vref value in DRW25. Basically, Vref is current by 2. So we have 1.9. We should set the Vref value as 0.8. So these are the components we need to make the assembly properly. Check the step and direction pin in extension board and match it with the DRV8825. Before that, we need to clean this driver. It's too dusty. Should not have any miscontact. So let's take a thinner and use a normal brush to clean this. Apply some bit of thinner and then clean on both sides, particularly in the pins. Yeah, now it's clean. Let's take the extension board and see where the step pin and direction pin is available. So step and direction is on the left side bottom corner. You should see same thing in the driver board. Yes, step and direction on the left side bottom. Rotate it and assemble it matching the pins. That's it. So we have all the pin outs and pin in as per the data sheet now. It's very easy for us to make the connections. Otherwise, we need to solder. Soldering is always a bit messy. Let's take all the components in. Let's start doing the wiring. You can see the cables. You have the respective connector, rotate it and assemble it to match with the grooves and slot. Yes, it's perfectly fitted now. Let's take the 12-volt supply in this. This is the board supply and the same supply to be given for the Arduino. You can refer the schematics as per like this. Let's do wiring as per that schematics. All you need to do here is see the pins correctly as per the schematics and do the wiring. Take the cables, male to female connectors. I will use digital input of 3 and 2. Sorry, it's basically an output for motors. So 3 and 2 I will take. Yes, it's a PWM connection. Connect them on the board and connect the similar color coding wires to the extension board as you see in the schematics. Please ensure that you're making the right connections the right place. It's very important. You can see the Arduino is having a lot of pins here. You can use any pins, but you use the same pin for software uploading. Okay, I will fast forward this video and we'll see after the wiring is done. You can see the center pin of the potentiometer is for input to the Arduino. So we should connect it properly for the analog input into the Arduino board. You can see A0 pin on the bottom. So we should connect that with A0 and to the center pin of a potentiometer. This is very important. Now all the connections are done. Now we'll give supply to this board 12 volt. I took SMPS of 12 volt to 5 ampere. Let's see how the connections. This is the SMPS I bought for a volt and 5 ampere. I will take a 3-core cable for connecting this main power supply, AC supply, and for the DC supply I will take the circular type of connector. You can see the line, neutral and earth here. I will take the 3-core cable from my old SMPS. I will connect them with line, neutral and ground. Make sure you're not making any mistakes with this. Make sure after making all the connections, you are doing pull-off test. Means you just pull the wire and check it is not coming out easily. Now I will take the circular pin connector for DC supply. You can see the negative polarity and positive polarity. Please make accordingly. Wiring is completed now. We should do the software coding. Let's go to the laptop. Oh, no. Let's try again. Let's see how to make this code for stepper motor control using potentiometer. Open Arduino software in your laptop. If you don't have, go to Arduino website, download the software and install in your PC. Initially, axle stepper library will not be available in your software. Please go to Tools option, go to Manage Libraries and select axle stepper. Type in the search box and give enter. You will find a lot of options, but I will select the first one and give install. You will see like this option. But I already installed, it's not showing me icon, so it's showing it already installed. So come to the coding section, open a new sketch and open this, and I already typed this code, so you can see the axle stepper.h library I have included, and for axle stepper I use 2 and 3 step and direction pins D2 and D3 in an Arduino. And void step, set maximum speed of 4000, and you can see the it will take the value from potentiometer for the input. You can see the analog read I have given for A0 pin in Arduino. So port value is less than 100, port value is equal to 0. You add these two conditions and into stepper motor speed, mapping the value to 0 to 4000 speed. And then finally provide stepper.run speed, this will run the stepper motor. That's it. So these two will activate based on your potentiometer value. Based on potentiometer value, it will set the speed from 0 to 4000, and the next stepper.run speed will initiate the running of stepper motor. And that's it. Close bracket, and you provide this upload symbol. Before that, you need to connect this Arduino with the USB and select the board. You can just verify or compile. Here it's showing fully qualified board name. Yes, I have not connected my board, so let me connect the board. Now I have connected the board. Let's see. So go to sketch, go to tools, go to board, select Arduino AVR boards. Under this I am using Arduino Uno. Select it and verify or compile. Now the sketch is getting compiled. Let's see. Yes, compiling is done. Now all I need to do here is I need to upload this software. Before that, we need to ensure the configuration of port. Go to tools, go to ports and select COM3 Arduino Uno. Now all you need to give is upload. Yes, uploading is done. You can see here done uploading, and that's it. Now the code is uploaded to your board. Let's see how it works. The code upload is done. Let's take out the USB from the laptop and from the Arduino also. Let's give the supply of 12 volt through the circular pin connector to the board, and let's set the value of Vref because it's very important, otherwise your motor will get stuck. You should set the value. There is a potentiometer in TRB8825 board. You can adjust it with a screwdriver and check the voltage across. You should get a 0.8. You can see in the multimeter I can read the values. Yes, I got 0.8 but 0.79. Yes, now the value is good. 0.8 is 0.8 I'm getting now. Let's see. Yes, now the motor starts rotating based on my potentiometer input. You can see the speed variation based on the potentiometer input. Rotating high speed and low speed and turning it off. Now the code is ready, circuit is ready, but we should make some kind of a box to place all these controllers in a single box with the input and output configurations. You can see at a very low speed. That's a good part of stepper motor. You can adjust it very precisely. Now the circuit is ready and perfectly working with variable speed using a potentiometer. I made this box to incorporate all the boards related to control the stepper motor. I created using Creo software and get this 3D model 3D printed. Let's see on part 2 of this video on how I made this.